October, November 2020. This is paper 4 and variant is 4-1. Question number 1. This question is from momentum. A particle V of mass 5 kg is at rest on a smooth horizontal table. A particle A of mass 2.5 kg moves on the table with a speed of 6 meters per second and collides directly with B. In the collision, the two particles coalesce. Coalesce means combined. Find the speed of the combined particle after the collision. We will use here the law of conservation of momentum. Let this is particle A, this particle B, mass of particle A is 2.5 kg. We represent it by MA. Mass of particle A is 2.5 kg and the mass of particle B is that is MB, that is 5 kg. Particle A, particle A of mass 2.5 kg moves on the table with speed 6 meters per second and collides directly with B. So this is the direction of particle A towards B. Now speed of A is initial speed of A, we represent it by UA, that is 6 meters per second. Particle B is at rest, so initial speed of particle B is equal to 0. Now we use uh, law of conservation of momentum. Momentum before collision is equal to momentum after the collision. Momentum before collision, MA UA plus MB UB is equal to momentum after the collision. After the collision, both the particles coalesce. So we will add the masses of two particles A and B here. We get MA, mass of A plus mass of B, and into V. This is V represents the speed of the combined particle after the collision. We have to find the speed of combined particle after the collision. We have to find V. Putting the values of mass and speeds here, 2.5 mass of particle A, speed is 6, and the speed of initial speed of B is 0. So this term will be 0. Right side, adding the masses of both particles. No calculating. We get left side is 15, right side 7.5 V. From here, V is equal to 2 meter per second. This is the speed of combined particle. Part B of this question is find the loss of kinetic energy of the system due to the collision. So, first we will find the kinetic energy before collision. Kinetic energy before collision 1 over 2 mv square. Now we will take the speed before collision. The speed of uh, particle A is 6 and mass is 2.5. Before collision, kinetic energy will be 1 over 2 m is 2.5 v square and 6 square. After calculating, we get 45 joule. This is kinetic energy before collision, and now we will find kinetic energy after collision. After the collision, the two particles coalesce. Two particles coalesce. So we will add up the masses of two particles. So 1 over 2 m a plus m b into v square. So we get 1 over 2 ma plus mb 2.5 plus 5 into v square, that is 2. V is 2. After the collision speed is 2 meter per second. We get 1 over 2 and 7.5 into 4. We get 15 joule. So loss of kinetic energy will be there's 45 joule kinetic energy before collision. After the collision, kinetic energy is 15 joule. So decrease your loss in kinetic energy, loss in Ke is equal to 45 minus 15, that is equal to 30 joule. This is the answer. This is the loss of kinetic energy.